All right, thanks for joining me again today. I wanted to show you part 2 of converting fractions with unlike denominators. So yesterday we had problems very similar to the one that's in front of you right now. There is a video that walks through this, but I want to show you how this problem is different than what your child is going to see today. So we talked about yesterday how we look at our denominators first, and we decide which one is the smallest. Okay, and 3 is the smallest. It's the smallest number. So before we do anything else, we always try to see, can I change it into a 9? So yesterday, this was the procedure of yesterday, we asked ourselves, does anything times 3 equal 9? And the answer was 3. 3 goes in evenly with 3 groups to make 9. But sometimes there will not be something that can be multiplied to equal the highest denominator. So now I'm going to show you how we did that today in class because it's a little bit different. So for example, excuse me, today we have 2/3 plus 5/8. So I'm going to look at my denominators. I've got 3 and 8. Okay, so the 8 is bigger. Okay, so I'm going to ask myself, does anything times 3 equal 8? The answer is no, because 3 times 3 is 9 and 3 times 2 is 6. So there's nothing in between that can equal 8. But I have to make these have a common denominator so I can add them all together. So what you're going to do is you're going to, if this happens where your 3 can't go into 8, or whatever your problem is, you're going to multiply the denominators together. So you're going to multiply 3 times 8, because then I'll get the exact same answer. So here's how I've taught students how to show their work. So we want to change 2/3, and we want to change 5/8. I do want to see this documentation of the conversion of fractions to prove students' thinking and that they understand what they're doing. So I'm going to multiply 3 times 8, and I know that's 24. So I want my new denominator to be 24, because then they have the same denominator and they'll be able to be added together in the end. So I'm going to ask myself, 3 times what equals 24? I should already know because these two factors multiply together to get 24. So if I'm not using 3, the answer must be 8. So 3 times 8 equals 24. If I multiply by 8 on the bottom, I have to multiply by 8 on the top. So 8 times 2 is 16. Okay? Now this one's going to be a little different because to get from 8 to 24, I'm not multiplying by 8. I'm multiplying by 3. So 8 times 3 equals 24. So then 5 times 3 equals 15. So now I've got a fraction with 24 as the denominator and another fraction with 24 at the bottom. Now they are like denominators, and I can add them together. So 16 24ths plus 15 24ths. Okay, and then we only add the numerators. We talked about that yesterday. That would be 31 over 24. Okay, now in the future, we will work on breaking this down a little bit more because the numerator cannot be left as a higher number, but we're going to get into that later on in our chapter of fractions. So for now, it is okay for your child to have a higher number here than it is here, because they'll learn that later. I don't want to overwhelm them with too much in the beginning. Okay, let's do one more problem, especially for my students that are listening in. So, again, I'm looking at my denominators because I have 1/2 plus 6/7. They're unlike denominators. These are not the same number. So I'm going to ask myself, does anything times 2 get me to 7? No, because 2 times 4 gives me 8, and that's over. And 2 times 3 gives me 6, and that's under. So they can't fit into each other evenly. So I have to multiply them together to find a common denominator. So I'm going to rewrite my fractions to show how I'm converting them, because a smart fox shows their work. All right, so if I add 7 times 2, that's 14. So I want my new denominator to be 14. Okay, so I need to think to myself, 2 times what gets me to 14? That would be 7. And again, if you forget, go back up here. Your answer is right up here. Okay, so if I multiply 7 on the bottom, I must multiply by 7 on the top. Okay, now we already multiplied by 7 here, so I'm asking 7 times what gets me to 14? 7 times 7 doesn't equal 14. I can't do the same thing I did over here. This one is 7 times 2 gets me to 14. I've seen a lot of students take this answer and write it over here, and that's not what we're doing. Really check your denominators and make sure you're multiplying correctly. So I multiply by 2 on the bottom, I must multiply by 2 on the top. So 6 times 2 is 12. Okay, so now I'm going to add 7/14 plus 12/14. I only add my numerator. 12 plus 7 is 19, and that's over 14. Again, you're getting a bigger number on top as your numerator. Later in our chapter, we'll go into how to convert that. But for now, it is okay for students to leave it like this as they get used to the process of converting the fractions, okay? And as soon as your child gets better at understanding how they're getting from this numerator to this numerator, they'll get to the point where they won't have to show this arch and this times by 2. We'll just know that they know it's by 2 because 6 to 12 is at times 2, 7 to 14 is at times 2. But in the beginning, for right now, I would still like to see the arch and what they're multiplying by, just to show their thinking. And then as they get more comfortable, they won't have to do this arch. This will be kind of in their head mentally. Okay? Again, I hope that these videos have helped you. They have 2 problems like this tonight in their homework where they have fractions that have to be multiplied, their denominators together, and they'll have 2 that were like yesterday's. Okay? So if you need more help, please go back to the previous video and let me know if you have any questions. Thanks for tuning in.